The first exponent rule that we're going to look at is the product of powers rule. What this talks about is when we talk about exponents, if we have, in this case we'll look at a variable with an exponent, any exponent, and we multiply that by the same base. That could be the same exponent, doesn't have to be. All we simply are going to do is take the two exponents and add them together. So an example of that would be something like 2 to the third power times 2 to the fourth power. The 2 stays the same, the base remains constant. 3 plus 4 is 7, so it would be 2 to the 7th power. Well, if you look at the examples in your packet, the first example we look at is the x to the 4th times x to the 6th. And all you're going to do here is you're going to keep the x, and 4 plus 6 is 10, so it's going to be x to the 10th power. The same thing holds true if you have more than one term. In a situation like this, there's no exponent for the first term, so there's a 1 that's understood to be there. So I'm going to keep my x, and now instead of just adding two numbers together, I'm adding 1 plus 3 plus 5, which gives me 9. The next example is a little bit different because it has coefficients. So I have my 3x squared times 2x to the 8th. And what you want to keep in mind here is this 3x squared can also be rewritten as 3 times x squared and 2 times x to the 8th. Well, I'm going to multiply those two together. 3 times 2 is 6. X, 2 and 8. Well, 2 plus 8 is 10. So I'm still going to do the same rules to put the x's together, and I'm going to follow my same rules for multiplication that I would have done had I just done 2 times 3. And just like example 2, what if there's an additional term? And this doesn't really change any of the concept here, except now you're going to multiply 2 times 5 times 3, which is 30, x to the third, x to the 6th, x squared, so you end up with x to the 11th power. And this is called my product of powers rule.